Okay, so the next video in the series of transformations is going to look at rotations and reflections. We'll begin by looking at rotations. With rotations, you need to know three things. You need to know where the center of rotation is, you need to know the direction you're rotating in, and you need to know the angle of rotation. Okay, so when we do rotations in the exams, etc., we're going to use tracing paper. Tracing paper helps us to keep track of the rotation, and I'll do some demonstrations in class if necessary, because they're not easy to do on this video. So, center of rotation. The center of rotation is the point which doesn't move. So this point, the center of rotation, stays completely stationary, and when you're using tracing paper, you will often put something sharp on that center of rotation, like a pen or a compass. The direction is going to be clockwise or anti-clockwise, unless it's 180 degrees, in which case it doesn't matter which direction you're going in. Think about that one. Okay, and the angle, usually at GCSE they're going to be multiples of 90. Occasionally you might get a 45 degree angle, but rarely. Multiples of 90 being 90, 180 degrees, or 270 degrees. Okay, so here's a rotation. As I say, we're going to do more demos in class, so this is just a brief overview. So A to A prime, we call that little dash a prime for some reason. So A to A prime. A to A prime is a rotation. Maybe pause the video now and see if you can work out what the center of rotation is, the direction, and the angle. So the center of rotation, we say it is about the origin. The origin being the point 0, 0. So that was the center, that was the point that stayed exactly the same, it didn't change. If you put tracing paper there and put a compass point on the origin and move the tracing paper, then the shape A would fit exactly on A prime. How far has it rotated? Well, it's rotated 90 degrees and it's rotated in the clockwise direction. Just to reiterate, this point here is the origin. Okay, next, let's look at reflections. All you need in reflections is a line of reflection. Now we tend to ask for straightforward lines, so these tend to be lines such as y is equal to 3, which is a straight line that is horizontal, x is equal to minus 2, another straight line, or something just slightly more complicated like y is equal to x. Let's look at an example then. We'll take this shape B, and after I've asked the questions, I want you to pause the video and try it yourself. So I want you to reflect B in the line y is equal to minus 2, and then once you've done that, reflect B in the line y is equal to x. So, have a go now and see how you get on. Right, so if we look at the first one, reflect B in the line y is equal to minus 2, well that is a horizontal line just here. This is the line y is equal to minus 2. Hopefully you remember this, or you can work it out. So on this line, at any point on the line, the y coordinate is negative 2. Okay, so reflecting the shape in that line, just imagine it's a mirror. If you really need a mirror in an exam, we can get you one. Otherwise, the shape B will just move to here. We'll call that B prime. Next, the line y is equal to x is that purple line which I've drawn. On that line, any coordinate has the same y and x value. So, for example, if you look at one of the coordinates, it might be 3, 3, y is equal to x. Also, you can say, well, the gradient of that line is 1 along, 1 up, and it goes through 0. Has no y-intercept. Okay, so to do the reflection, a good tip is to rotate the page so that the reflective line is facing straight forward. Otherwise, you can take a point and make sure that it's the same distance away from the line of reflection. So those two purple points are equidistant from the line of reflection. If we take another point, just there, that you can see that's kind of 2 diagonal squares away from the line of reflection, so its mirror image will be also 2 diagonal squares away from the line of reflection. We could connect those lines, and now that you've got one side of the shape, you might be able to fill it in. If not, you could, draw another point and check that it's the same distance away from the line of reflection and connect all the points. Okay. So I think we'll end the reflection rotation video just there.